Today I'll follow up on two earlier blogs that I did on installing Portworx on top of VMware and on top of EKS, and now enabling disaster recovery from on-prem into the public cloud. And for that, we're going to use our documentation from Portworx, which, as always, and what we're trying to achieve here is this async DR nodes across different regions or data centers. Basically replicating an entire application from the source, which is my on-prem VMware environment, into the destination, which is my AWS EKS cluster. Quick run through the environment. This is my VMware environment where I basically have my master node and 3 worker nodes. This is my EKS cluster that's running in AWS where I'm replicating to. And finally, I've deployed a small pet clinic application, which from the IP address you can see is now running on the VMware environment. To make sure that this is an actual demo, let's just add an owner, and I'll call the owner Portworx, and the last name is disaster recovery. Give it an address and then also a phone number. There we go. We add that, and also we add a pad for that, PX-DR, and the date of birth is just some dates, and it's a hamster. So there we go. We've added some small information to this application. Looking at the clusters, I can see that I have some resources that make up the pet clinic application on my source cluster. So 2 pods, MySQL and front-end application, 2 services, 2 deployments, and a persistent volume claim. On the destination cluster, there is not even a pet clinic namespace, right? So what we're trying to do is replicate everything in this pet clinic namespace to the remote system and go from there. Because we need a specific license for PX-DR, I've went ahead and already activated a license that includes disaster recovery that's required to be able to actually run this. Good. So now that we have our environment set up, let's get started with the documentation. So there are some requirements. Make sure you read through that. For now, I'm just skipping that. Okay. First, we need to install store Cuddle, which is the command line utility for PX-DR on both clusters. So let's go ahead and just copy and paste the commands, and that will make sure that we're able to use that. And since we're replicating to an EKS cluster, we actually need to follow this procedure on the on-prem environment to basically share the AWS credentials with the stored environment, allowing the on-prem environment to reach out to EKS and make any changes that it requires. It uses the credentials from the AWS CLI. So if I look into my on-prem cluster, I've authenticated into AWS, and that's resulted in this file being created on my source environment. And then I can use this command to basically create a Kubernetes secret out of that file. And once I have that, I can share that file into my store pods. Now, instead of editing the deployment directly as specified here, I'm actually using the operator. So instead of editing deployment, I can actually change my storage cluster object and make the changes through that. So I will go ahead and copy this piece of code and basically go into my source cluster to edit the storage cluster. There we go. And then if I go down to the stork parameters, what I'll do is I'll paste this in. So basically I'm telling that Storks needs to mount this volume on this location within the pod, and it needs to use the secret that we've just created. If I save that and then I do a watch on kubectl get pod in kube system, we'll see that the operator makes sure to recreate the pods with the correct information. And if, for example, I look into this pod with a k-describe system, there we go. You can see that it has actually mounted that volume onto the pod, and the volume is mounted into the container on this path that we specified earlier. Good. So going back now to the documentation, we can close this out. We have provided Stork with the AWS credentials, so we're happy to get started. Next step basically is to make sure that the on-prem environment can access the EKS cluster over the internet, and therefore we need a load balancer on the public cloud. Again, here it mentions edit the service manually and then change that to load balancer. Since we are working with the operator, also this part we're doing through the operator. And for that, we're basically adding this annotation to the destination cluster, so to the EKS cluster. And thereby saying that it needs to use a load balancer for the Portworx services. So I'll just add the annotation here and save that. And then if I look at the services in the Kube system namespace, you can see that these are now load balancer services, and there's also a DNS name associated with those services, which is obviously required for connectivity. So now we can go ahead and create the cluster spec. One step to take in mind, if we're using an external object store, we need to create the credentials for that object store before we actually generate this cluster pair. Creating the credentials is explained in a different page called here, basically creating the credentials to Pixie Cuddle. It allows you to create the credentials. You need to specify the information required, and that allows you to specify the credentials. I've already done that so that I didn't have to record my secrets in this recording, but I can show you the end result by SSHing into both Kubernetes Portworx pods. First thing I did on the destination cluster is to generate or to check the cluster UUID. So that's this one listed here. It's a unique ID of the destination cluster, and we're specifying that in the credential that we're creating on the node. So next thing I did was basically create the credentials, and it's listed here. The first part needs to start with cluster pair underscore, and then the second part is just the UUID of the destination cluster. And everything else is just regular S3, nothing specific there. I also created that same credential on the destination cluster. Let me quickly show that too. There we go. Here we can see it's the same. And again, it's the same UUID, right? So both credentials point to the cluster UUID of the destination cluster, and both point to this exactly the same bucket on AWS, which is being used for the migration of the volumes, but also the objects. So clear that out. So then once we've done that, we can close this out as well. We can now basically go ahead and generate our cluster pair, which is really connecting those two clusters together and enabling any form of replication. So let me copy the cluster pair is generated on the destination cluster. So I do that on my EKS cluster. I want to migrate the pet clinic application or the pet clinic namespace. So I generate a cluster pair for the pet clinic namespace on the remote cluster, on the EKS cluster. And then basically I copy the output of that command to my source environment. Sorry for all the typos. There we go. I paste that. So now we have all the information of our destination cluster on my source cluster. And the next thing I'll do, it's documented as well, is I need to change the options field. So let me go back to the documentation. Basically here it says that I need to enter these values. So the IP address of the remote cluster, the port numbers, those kind of things. So let me just quickly clear that out a little bit. So first the IP address. For the IP address, what we're actually using are the services that we've just created, the load balancer DNS names, right? So we're just going to copy out the DNS name and paste that in here. Next is we're specifying the port number, 9001. And finally, we need a token. And let me just quickly create that token and copy it in. So now I'll just execute into the Portworx pod. This will generate the token for the destination cluster. There we go. We'll save that. And then we can save this file. So basically in this documentation, it also points on how to create that cluster token and everything. So just follow along. If you're following along, use that to create that token. And then we basically created our cluster pair object. So with that, we can go ahead and apply the cluster pair to the cluster. And then we can use store Cuddle to check the cluster pair in the pet clinic namespace. We can see that it's being created and both the storage and scheduler status are ready, which means that both clusters are able to reach the object store and the on-prem cluster is able to connect to the EKS environment through the Elastic Load Balancer service that we've referenced. So we're good to go. Next step is basically to create a schedule. I'll just go ahead and use the default schedule for this. Nothing specific that I want to change there. So just clear out what was in there. Then just copy this over and paste it in here. We're defining a policy interval of every minute and then also a daily, weekly, and monthly schedule in this policy. So that's really when the replication is taking place. Very flexible. Next, we'll just apply this policy onto our cluster or this schedule policy. And then finally, we want to actually create the migration itself. So I'll go off with the migration schedule as it is here. vi migration schedule.yaml. I'll paste this out. The namespace that I actually want to migrate is pet clinic. Maybe the name that I want to use should also be pet clinic migration schedule. I'm using that remote cluster object that we created with the cluster pair. I'm including all the resources and I'm not starting anything at the destination site. So I'll just change the namespace also here to pet clinic, and we're referencing that test policy. Now before applying this, let me go back to my EKS cluster and there just create a watch on all resources in the pet clinic namespace so we can actually see what's happening. Right now there's nothing in that pet clinic namespace. As soon as I apply the migration script, what will happen is that the migration script should start backing up the objects and the resources and the volumes, storing that into that S3 object store, and then the target cluster, so the EKS cluster, will basically download the resources from there and start working on that from that side. To follow that off, we can basically describe our migration schedule in the Pet Clinic namespace. So here we can see that it has started a migration. On the right side, we already see the persistent volume getting created. We can then go into that migration and then we can track the status of the migration, and it has already completed successfully. On the other side, we can also see that the persistent volume was created, the deployments were created, and the services were created. But as designed, the pods have not been started yet. That was really what we wanted to do, so that now every minute we're doing replication from my source environment into my target environment, and only in case of an actual failover, we want to trigger the application on the remote side. Now going back to my EKS cluster, just so that we can see that this all works out well, let me go into one of the worker nodes and just try to access the Pet Clinic application through one of the worker nodes to the node port. There we go. Basically, it's not working right now, which is what we were expecting to see. And we will just delete the namespace Pet Clinic on my source application. That will obviously cause my application here to fail, so I will not be able to reach out to that application anymore. So next thing we'll do is we'll go out of the watch and then basically use Stork Cuddle to activate my migrations in the Pet Clinic namespace. And this is really what triggers the actual failover. So basically activating the migrated resources on the failover side. Once we execute that, we can see that the replicas are getting updated for the deployments in the Pet Clinic namespace. We can see that the pod is getting created. First, the MySQL pod needs to go into a running state, and then the front-end application will go into a crash loop back off until it can connect to the MySQL application. And as soon as it finds the MySQL application, also the front-end application will go into a running state. And there we go. So 33 seconds. If we now go back into my browser and do a refresh of my application, I can see that the Pet Clinic is now in my EKS environment. If I look for the owners, I can actually find the owners, and my Portworx disaster recovery with my PX-DR hamster is still there. So that's it for the demo. I hope you enjoyed watching. See you next time.